If a mapping from G1 to G2 be a homomorphism, then the set H of all those elements of G1 which are mapped on the identity element of G2 is a normal subgroup of the group G1. Say we have a group G1 and a group G2. Let A1, A2, A3 be the elements from G1 such that these elements are in a subset H. Then according to the statement, these elements are mapped to the identity element of G2, that is G2 is equal to F of A generally. Okay, then we come to the proof. Now by looking at this one, or H is collection of all the elements A such that Fa is equal to E2. Okay, just by looking at this, I mean from the statement where A belongs to what? G1 and E2 belongs to G2. We have to show that this H is a normal subgroup of G1. Before showing that, first we will show that it is a subgroup of G1. That is, we have to show this one so that it is a subgroup of G1. Okay, so let's start. Now for AB belongs to H, we take element AB from H. We have, now we have to go according to this one. F of A, okay, star B inverse. Now why do I take the inverse? Because I want to show that A star B inverse belongs to H. It is equal to FA star FB inverse. Why? Because it is a homomorphism. Okay, that's why I can write like this. So what is FA? FA is E2 star. What about FB inverse? B belongs to H. So FB inverse is E2 inverse. This is nothing but E2 only. Okay, so FA star B inverse is equal to E2 implies that A star B inverse belongs to H. Why? Because if FA is equal to E2 and FA star B inverse is equal to E2, then FA is nothing but FA star B inverse. So this shows that A star B inverse belongs to H. Thus, AB belongs to H implies A star B inverse belongs to H. Hence, H is a subgroup of what? Of G1. Next, we have to prove that it is a normal subgroup of G1. To show that H is a normal subgroup of G1, we have to show that X inverse star A star X belongs to H, where X and X inverse belong to G1 and A belongs to H. Again, if X belongs to G1 and A belongs to H, then we go according to this one. F of X inverse star A star X. Why do I go by this? Because I want to show that X inverse star A star X belongs to H. Since it is a homomorphism, then I can write F of X inverse star F A star F X. Okay, leave this one as it is. Now what is FA? FA is like this, star Fx. Fx inverse star Fx star Fa. Fx inverse with Fx is the identity element E2. Okay, and here also Fa is nothing but E2, so we write E2 and it is equal to E2 itself. Okay, so from here Fa is equal to E2. Here also Fx inverse star A star X is equal to E2. It implies that for X belong to G1, A belong to H, implies that X inverse star A star X belongs to H. Hence we say that this H is this set H is a normal subgroup of G1. I hope it is clear how to do this or how to prove this theorem. Thank you for watching.